Open to page number 4.19 in CENGAGE. The concept we are going to do is inclined plane. So motion of a body, one dimensional motion only, one motion of a body on an inclined plane, on an inclined plane. This is what we are going to do now. Did you open the page number 4.19 in CENGAGE? First part is little easy to understand and diagram is also not difficult. See, there is an inclined plane. Let us take an inclined plane. This is an inclined plane. This you have to visualize three-dimensionally, please. Imagine your book, how your book will be that way. Open your book in an inclined situation. Put your book on a slope, like a slope. Open your book, for example. You see, this is the situation. You can see me. This is your book, right? Okay. If you open your top face of your book like this upwards. So this forms an inclined plane. Is this understood? Hmm? So
Yes,
this is the
sir.
situation we are speaking of now. So this makes an angle theta here or not? In between my face is visible. See that? That is an inclined plane. Now we are going to deal the situation of an inclined plane. Okay? The inclined plane makes an angle theta and there is a body here. Let us imagine the body whenever say a ball or something like that. Okay. So what happens to this ball which is sliding down without rolling, sliding without rolling. So let us take the body not as a ball actually because ball means you may think it is rolling without rolling. Okay, body without rolling. So this is the body. So what happens? Its gravitational acceleration is purely downwards. Is it or not? This is G value. The height of the inclined plane, let us consider as some h. Let us take these alphabets A, this is some B and C. This is the inclined plane. The body of mass m is sliding down the inclined plane. Another body of mass m again, same body, mass is not important here, is falling, freely falling. Freely falling means initial velocity u is equal to 0. Here also freely sliding. Here freely sliding down. This is sliding body. Sliding without rolling, okay? And there is no friction. Sliding down the inclined plane. This is freely falling in air. What happens now? We imagine, we generally feel that these two bodies are traveling with different velocities, something will happen. No. Both the situations are one and the same. Only difference is time. Time taken by this body will be higher than the time taken by this body. Rest all things will be same. The velocity upon reaching this point here, that is final velocity v1 in this situation and final velocity v2 in this situation will be the same. How? We're going to do that. Let us take this as body 1 and the sliding body 2. Okay? Correct? So, let us consider the body 1 which is freely falling from a velocity u because it's freely falling from a height h. Then it reaches the ground with a velocity v2. So what could be the formula? v2 square. So I am writing this simply v2 square minus u square is equal to, or if this v2 is confusing, I will better write vd, means direct. Understood? No? V direct and v sliding I will put like that. So it will be easier for you to understand. Okay? I'll name this as v direct and this is v upon sliding. Now it's clear. So v direct square minus u square is equal to 2 gh. Is it or not? This is what will happen. U square is 0. So v square minus 0 square is equals to 2gh. What would v direct be? This is v direct. Root over 2gh. Now let us see what will be v sliding. To find out v sliding, you need to know this length of sliding. This length of sliding is smallest. How do you know that? By using what? How do we do? How do we get that?
Hypotenuse, sir.
Opposite side by hypotenuse. Sine theta. We need to use Sine theta is equals to opposite side h by sliding length s. So what would that s be? H by h means capital H only, no problem. Okay, take it as capital H. Capital H by what would that be? Sine theta. Is it or not? So 1 by sine theta we have an idea. It's cosecant theta. So you can write that as h cosecant theta. Is it understood? Now we have to use this s and we have to apply v square minus u square is equal to 2as. But what is acceleration along the slide? That we have to find out by using
It's less than a Vs, sir.
yes, Kritika. There are two velocities, there are
It's less than
accelerations, is it or
Vs.
not? The acceleration splits as two components. This is one component and this is one component along the inclined plane perpendicular to the inclined plane. Is it or not? Yeah. Actually, this splits this way. I am writing it that way. Okay. So this component of acceleration is equal to how much? G sine theta. What is theta? This theta is represented here. Is it or not? So this component of acceleration will be G cos theta. And what will this be? G sin theta. Is this understood? Both of you.
Yes, sir.
I
So
didn't
now,
understand the G cos theta and sin theta one, sir.
yes, I will tell you. This is G. Huh? There is one component this way and there is one component this way. The theta is here. Theta is not here, here. So if you enclose this right angle triangle, then you will get this value. Why? If you enclose this, you will get this component and you will get this component. Is it or not? Is it understood till here? No, no. Okay, I'll make it clear. See, you have to enclose it. Ah, now the right angle triangle has been formed. So you want to find out this angle, this theta. So I will write this as gx. I'll call this as gy. This gy is this gy. This is gy. Okay, and this is theta. Now if I write cos theta, what will I get? Tell me, Kritika. Adjacent side by hypotenuse. This is hypotenuse. Okay, is that clear? So gx by g. So what would gx be? G cos theta. Is it understood? This will be cos theta. Similarly, if you write sin theta, understood? Opposite side by hypotenuse. So opposite side is gy. Is it understood now clearly?
Yes, sir.
How you got g cos theta? Then obviously you'll understand this is g sin theta. Is it understood? Hmm? Clear?
Yes, sir.
Yes, sir.
New things will keep coming. So what we have to do now is we have to apply same kinematic equation for the sliding situation. For the sliding situation, the acceleration is given by g sin theta. And for the sliding situation, the length is given by s. What is s equals to? Just now we got h by sin theta or h cosecant theta. Is it or not? That's what we got. Yes. So we have to use that. Again, the initial velocity is 0. That's no difference. Final velocity we don't know. V sliding. Again, what do we do? V sliding square minus u square is equals to 2g. What we have to use? G
Sir,
sine.
that is the sliding length now, sir. H cosec theta.
Yes, correct. H cosecant theta. This is acceleration. A. What is the h? H is s. That is h cosecant theta. H by sin theta, no? Just now we did, is it or not?
Yes,
I
sir.
will
Yes,
doubt,
sir.
I'll write again. What is sin theta from this diagram? Capital H by S. Opposite side by
Yes, sir.
hypotenuse. What is SC here? H by sin theta. Understood or not?
Yes, sir. Yes, sir.
Yes, sir.
So now you see cosecant into sin is anyway 1. No difference. 2gh again you're getting. Is it or not? Cosecant
Yes, sir.
theta and sin theta gets cancelled equal to 1. Is it or not? It is h by sin theta. Okay. So again we got the same answer for velocity. So the final velocity Vs is the same as 2gh. We are going to do this concept again in work power energy. That is because the initial potential energy at this situation is equal to initial kinetic energy at the bottom. That is the reason. Theta is immaterial. Velocity will never change. That is because of law of conservation of energy. That is one more basic reason. Is this understood now? So what we got is V direct was exactly equal to V sliding. Then what is the difference? There should be some difference, no? The difference is the time we are going to get now. Is it understood now, clear?
Yes, sir.
Yes.
Now what we are expecting to find out is the time direct and time sliding. Time taken in direct freely falling body and time taken for sliding body. T sliding. So how do you find that again? Which formula will be useful for us? Tell me. Any idea? V is equal to U plus AT, or which formula? S is equal to UT plus half AT square. Which formula is useful? Only two formulas have time in it. S is equal to UT plus half
U
AT
plus 80.
plus half AT.
Sir,
The formula, no? V is equal to U plus AT will not. Ah, yeah, that is also useful. That is also useful. But S, we have S, no? We already have S, is it or not? That is the reason. Yeah, we can find from V is equal to U plus AT also. You're right. From that also we can find, from this also we can find. From this I am finding, and I'll show you that both will give you the same answer. No problem. What is S in the first situation? H. H. What is S in the second situation?
H by sin theta.
Right? Sin theta. So use this here. First case, freely falling body as direct is H is equal to U is 0. So T is anyway not to be worried about. 0 into T plus half. A is G. T is T square. T direct we call it now. So what would be your T direct in this situation? 2H by G root over. Is it or not? This is what we are going to get, T direct. Yeah. Let us see the time direct in the sliding situation. Sliding situation. S sliding is S itself. It is H by sin theta actually. Yeah. I will find out the same time from V is equal to U plus AT also. Okay, we'll get the same answer.
Sir, in the H, what is beside T, sir?
Huh? U 0T.
Okay, sir.
0, no, that is 0, right?
Yes, sir. Yes, sir.
0 into, what is the formula? UT. 0 into T
Yes, sir.
plus
Yes,
half
sir.
GT square, AT square. So that is, this is S now. A sliding situation. S is equal to UT again same. UT sliding plus half. Instead of G, you write G sin theta, is it or not?
Yes,
Hmm?
sir. Yes, sir.
G sin theta. T we do not know. T sliding square. Yes? Understood till here? Hmm?
Yes, sir. Yes, sir.
So simple. So this is anyway going to be 0. 0. What will this be? This sin theta will come down, is it or not?
Sin square theta.
Very good. Sin square theta. Yes. It will be H by,
2h by sin square theta.
yeah, very good. 2H by sin square theta is equal to 0 plus 0 is anyway not to be written. So what you are going to get here? Only T. That's it.
Root 2h by a sin theta.
I will write it. Ts square. So what will Ts be? Root over 2H by sin square theta. So if you take the sin square theta, of course G will be there. You missed out G. G will be downstairs, no? G. Hmm? So what will our Ts value be? Root over 2H by G is anyway there into denominator sin square theta will come out of the root and go upstairs cosecant theta. You want to write that? I'll write it neatly. Wait. What should I write that? So I will get T sliding as, are you getting each step? 2H
Yes,
by
sir.
G into outside 1 by sin square theta will go up as cosecant theta, not square. Is it understood?
Yes, sir.
Yes,
Yes,
sir.
sir.
Cosecant theta. So this is what we will get. Now tell me, is TS greater or TD greater? Obviously TD is greater, because as the value of the slide angle increases, what happens to sine theta? Upon higher angle, sine theta increases. But cosecant theta decreases,
Sir,
no? Sine 90 is very high. Sine 0 is very less. But 1 by cosecant is reverse of sine theta. Is it or not? So, as theta increases, I'm writing, as the theta increase means going towards the vertical. As the theta increases, cosecant theta decreases. Is it or not? Therefore, T sliding is definitely less than the T direct. Is it clearly understood or not?
Sir, I did not understand the as theta increases and cosecant theta.
sir,
What is sine 30
cosecant
degrees? Tell
theta
me.
increases or cos theta increases?
Okay, tell me sine 30 value.
1 by 2.
Next higher value, sine 60 value. Tell me sine 60 you don't know?
Root 3 by
Root
2.
3 by 2, sir.
Root 3 by 2 means how much? Can
3
you
by
tell
2,
me?
sir.
How much is root 3 by 2? Is it more than 1 by 2 or not? Yes, it is 0.8666. It is higher than 0.5. So as theta increases, sin theta is increasing or not?
Yes, sir.
Similarly, sin 60, sin 45 also you see, sin 45 value will be less than this but more than 1 by 2. You check the values. Sin 30 is 0.5. Sin 45 is 1 by root 2, means 0.66 something you will get. Then sin 60 is 0.866 you will get. So the sin, as theta increases, sin theta is increasing or not? Understood?
Yes, sir.
So that means 1 by sin theta will decrease, no?
Yes, sir.
Is it clear? Understood? Is it understood or not? Very easy. So common sense also tells you the same thing. The sliding time will take more and direct time will be less. Directly it will fall fast. It's not about faster. Huh? Again you see, we should not say faster because velocities are again same. It is not about faster or slower. It is about more time and less time. Faster word we should not use in English because both are taking the same speed to reach the ground. But this because of acceleration difference and difference of the distances traveled by them, times taken are different. This time is more and this direct time is obviously less. It's not velocities will not be more because the angle because why velocities are not different even though they are traveling on angles. That is because the law of conservation of energy says that whatever path you follow, irrespective of the path you follow, work done is same or energy is conserved. That is the reason this is happening. Okay, this is understood.